Alright, in this video we're taking a look at a problem with either law of sines or cosines, depending on which one. So perhaps up here should say or. We're given a situation with a figure skating routine where these two people, Jackie and Peter, skate apart with an angle of 15 degrees between them. Jackie's going to skate for 5 meters, Peter's going to skate for 7, and it wants to know after this has been done, how far apart are they? So the idea here is that we're just going to give them two directional placements. It doesn't really matter. It doesn't specify anything other than that they're 15 degrees apart. So we're going to put a little 15 degrees in there. And let's say we let the left one be Jackie for 5 meters and the right one be Peter for 7 meters. I'm going to leave it drawn like this for just a moment because I want to illustrate something I mentioned in previous videos where we talked about these ideas of side, 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 or side, angle, side, angle, angle, side, all these different combinations of sides and angles. When I look at this, without finishing the triangle, I can see literally that we have a side, an angle, and a side, kind of in that order. In fact, if I kind of listed it out like this, we can see the side, angle, side piece pop up. So the idea is I can use that as a checklist to say, okay, I know this is a law of cosines problem. Other things I can do to kind of convince myself is just say, well, look, I only have one angle. The only time I can have one angle and still use law of sines is if I have the opposite side of that angle. So I look over here and I go, well, I don't know what that is. In fact, that's what they're asking me to find. And that's one of the places where cosines excel. You can use law of cosines to find the side that's missing if you have its opposite angle and the other two sides. So if we call this, I don't know, let's call this side C, we would go with our formula c squared equals a squared plus b squared minus 2ab cosine of big C. Now in this problem, because I'm choosing these variables the way I am, you can really just pick whichever one of these you want to be little a and little b. It's ultimately not going to matter because they're really interchangeable in this formula for the most part. The only thing that really matter are the thing we're looking for should be over here, and the angle we are given should be inside a cosine here. We also know that the square is really kind of extra, so we're going to go ahead and take the square root of both sides here. That way we know when we go to work this, we can just plug in values. So we just go in and say, well, that's 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of 15 degrees. And while I say that very matter-of-factly, that is quite a mouthful to talk through. But once you have that, now I will say this depends on the calculator that you have to work with. But I have one of these. I know online you can use things like Desmos to make this a little bit easier. We're just going to go in, and first of all, actually, before I start typing things, I'm going to go to Mode. You should do this for any calculator, whether it's a Google calculator, Desmos, an at-home calculator of any kind, a TI-84, especially here. Notice I'm in radians right now. But in my problem, I was handed an angle measured in degrees, which is very typical for law of sines and cosines type of problems. We're going to go ahead and change that to degree mode, and then we'll take our easy route. All I have to do is type that in exactly the way it is. I don't have to simplify anything because the calculator knows how to do order of operations. It's going to save you a ton of time and effort where you can just plug it in. You also want to be careful. I've made some mistakes in the past trying to rush through calculator plugins. Just double check that everything's typed in correctly. And once you've done that, I don't need to know what any of those things squared are. I don't need to know 2 times 5 times 7. I don't need to know what cosine of 15 is. All I need to know is this right here. And since I was not given a particular measure for rounding, we'll just go ahead and go with the traditional 2 decimal places, and we'll say about 2.53 meters. And then we could go through and we could do some checks on this if we wanted to. This is one of the nice things. I could bring law of sines back in now, and I could just try to check and make sure I've done everything correctly. The downside of that is I would need to know what the other angles are. So, some people look at that and go, okay, well, I'll use law of sines, law of cosines to do that. I would need to pair some things up before I could. So it's a lot of extra work to check yourself here. So instead, what might be better is to use a little intuition. I'm going to take a look at this angle and go, well, this is 15 degrees. That means it's going to be significantly smaller than these other two most likely, especially since they're very similar in size. I can imagine that these two angles are probably, I wouldn't say super close to each other, but much closer to each other than they are to this one. Because 5 is closer to 7 than either of them are to this guy here. In fact, 5 is almost double this one. So we're expecting this angle to be definitely a good bit bigger than this, and this one's going to give an even bigger angle. So this 15 degrees, that smaller angle there, feels pretty good to me. So this is all I would have to do to find that other side. And notice I don't have to find the other angles, because in a word problem, they often do this, where they ask you a specific value to look for.